Well, hi, and welcome to my shop, and thanks so much for coming and joining me here. So I'm not alone with this radio. Yesterday, in the last video done yesterday, my goal was to redo the alignment, but no, I decided to test all the tube pin voltages, and I only made it to the output tubes before I found something curious, which was a difference in the plate voltages. In the end, after examining it, I kind of concluded that the fault, if I could even call it that, must be with the output transformer primary windings not being balanced for some reason. I don't think this is normal. I don't think it's in the range of normal for a radio. I think what would be normal is to measure both those plate voltages the same. So I kind of ended the last video just saying, well, I guess that's the situation. Well, today, I continued thinking about it, of course, and I've realized I can go a little further, do some simple tests on the output transformer itself. And so the way this works is the B plus is presented to the two plates through the output transformer primary because of a center tap into the primary. So if I can measure between here or between here, I will measure the individual windings which are feeding each individual tube. So getting these points is easy. These are just the plates. I just put my ohm meter on the plate terminal. Getting the middle one is just as easy because, in fact, the middle or the center tap on the primary of the output transformer is connected directly to the two screens on these same tubes. So basically, if I put the ohm meter between screen and plate on one tube and screen and plate on the other tube, I will read just the resistance of the output transformer. I expect it to be quite low. I gotta think about this now. That must be providing the plate resistance that the tube requires to operate. So maybe the resistance of the winding is quite high. I've never done this before, so I'll take a wild guess. I'll put this on 20,000 ohms to start. We'll see what we end up with as we go along here. And of course, the radio's not been turned on today at all, so there's no charges in it. And it was 3 and 4. 3 being the plate, 4 being the screen. So we'll try this one first. We'll see what we get. 860 ohms. Let's try it on this scale. This should get exactly the same reading. Got a nice new battery in there. 865 ohms. And we'll try the same thing, the other part of the primary winding. Whoops. Huh. More than 2,000? $4,000. 4,000 sounds like a more likely number for a plate resistance. 4,000 on that one. 800 on that. Wow, that's not a small difference. Let's look on the schematic and just see if we can find any information about the resistance of the plate here. What are the chances it's going to tell us? Once in a while that kind of stuff is written in schematics somewhere. Oops. Too many different viewers to know how to operate properly. So look at that. They give it for the voice coil. Yeah. Is there by any chance a note? A fat chance there'd be a note down here. They'd put the note right next to it if they were going to put a note in. Okay, so another way is to look at what is the plate resistance, especially for 6F6. I got a 6V6 in there, but that shouldn't make any difference for the measurements that we're doing. Plate resistance for a 6F6. You can kind of think of the tube as a variable resistor. And so if you have, if you supply a voltage to a variable resistor, the voltage doesn't change. The current through the resistor is changing as you vary it, but the voltage doesn't. And if you're trying to drive another stage with this voltage, it's not changing. So that's why you have to put a plate resistor in to create two resistances in series. One of them you vary, and the voltage will show up going across the other one. Get that. Right, I get such a laugh out of myself sometimes. I shouldn't. 6F6. 6F6. Can you tell yourself jokes and laugh at them at the same time? Often I'm living the joke and laughing at it. 6F6. What can you tell us about plate? Let's look over here. Down here for ohms. It's easier sometimes. So that's a cathode resistor, ohms. Plate resistance. Oh my gosh, 80,000 ohms. So that's plate resistance, not plate resistor. That's on fixed bias. On cathode bias, they don't give one. So I think there's something lacking in my knowledge here. There must be some reason why they don't bother giving one under cathode bias, which I don't understand. So another hole. Here's one here. Load resistance. This is what I'm really looking for. 7,000 ohms all the way across, no matter how you operate the tube. 7,000. So it's looking for 7,000 ohms. So you would expect to find that the primary, the overall primary, is 14,000 ohms. Split in two is 7 each to give that effect. Now I don't want to say too much about it. There's an inductor happening here, and it's the inductance which is reacting with the current, the tube current. I don't want to say too much, but let's just measure it again. Clearly this is the problem. But what else could cause these kinds of readings other than the let's just do it again here. So this is the one I'm getting 4,000 on. Whoops. 4,000, but down here only 860. Yeah. The higher resistance must mean more windings. The more windings will mean the transformer action is less on the side with the more windings on the primary than the side with the less windings. Assuming what has happened here is some of the primary windings have shorted. So where there used to be, say 200 turns of wire because of a short circuit, now there's only 60 turns, giving the low resistance. I have to assume the low resistance is the wrong one. The low resistance is the the low resistance is the cooler tube. The low resistance is the cooler tube. The low resistance should be giving a higher B+. Do I remember right? We're getting the higher B+ and the lower resistance together. The higher B+ because the lower resistance isn't dropping as much. A higher B+ generates more current in the tube, making the tube hotter, but it's not. It's the other tube that's hotter. Well, I got this all backwards. Rubbing it's not gonna help, Jim. What are you doing? Well, I think maybe I'll leave it at that for now. I'm not sure what to do. Is that tube getting too hot? The hot one getting too hot? It's getting a similar temperature to the rectifier tube. Assuming the rectifier tube is operating normally, I think we could say that temperature on an output tube is not that far out. It's actually the cooler tube which is not running the way it's intended. I'm not sure that's true. I may have my thoughts all mixed up. I probably do have my thoughts all mixed up. Okay, so we're going to get back to measuring the rest of the tubes and see if there's even more here to start head scratching about. I'm going to get us all set up here. Still have a short on the antenna. We'll everything should be ready to go. More famous last words. Hey, what happens when you throw this switch? That light just barely comes on. Not much of an inrush on this radio. And we're going to try my newfound instrument here. I got an idea of what to do with this. I have an idea. That's usually the start of the downward spiral. Having an idea. Now, I haven't bothered putting the chart up on the screen here. Whoops. Okay, I'm going to stop for a few minutes and get my video lined up here. Okay, I think we're ready to go here. So we're looking at the second detector. It used to be that the what we would call the detector tube was often called the second detector, because what we call the mixer tube was called the first detector in the early days. So that's why this is called the second detector. But really, in my mind, it's the detector tube. So 6SQ7, let me grab my probe here. Remember to flip it back to DC. Wow. Put a star next to my name for that one. Here we go. DC positive, 500 volts on the scale. Let's start with the B plus first, just to double check my meter and everything. There it is, 250. And what is that? Other, very, very low. 65. 250 for the output tube, 65 for the rest. I think that's where we're heading here. Let's see. We look at the detector tube, and we start on pin number 1, which is empty. 2 is 0, 3 is grounded, 4 is 0, 5 is grounded, 6, 85 volts on pin number 6. Pin number 6 would be, according to the diagrams, this one. Okay, let's try another one. If we look at the key, we're back 876. Pin 6 from the key. 6. There we go. And the voltage is 95 volts as opposed to 85. I can't be too concerned about that. And there's nobody else here to take a look at. Just that, just the plate. Okay. The next tube along, let me just pull this down here. Again, is the IF amplifier tube. So the IF amplifier tube is for this one here. Did I have my arm in front of the camera there? Maybe I did. Maybe I weren't able to read the voltmeter too well. Let's see if I can just fix this up a little bit. Okay, so we're looking at pin number 1, 2, 3, 4, 5, 6 again. Pin 6, 95 volts this time. That's what we saw in the other one. And pin 8. Oh, pin 6, screen grid, pin 8 plate. Oh, 245 on the plate, which is okay, so there's the key, just as it's shown right in the diagram. Right there. Plate would be just right here. I don't know 150 scale here. Let's go. I'm on the 500 scale, so straight up would be what we're expecting here. And key 8-7. Oh. Well, no, 6 is 95. 6 is 95. Let's try that again. 6 is 95. So 876. And we're looking at 65 instead of 95. That's quite a bit off. And we're full voltage on the radio today. It's a nice fresh 121.7 volts. So this is a little low. Ooh. That is a little low. Might be a resistor that you do something with. 95 there, and then the plate should be now back here. 250 straight up. Plate is number 8. So it's 250 straight up. Plate is correct. Screen appears to be low. Look at the screen again. Oh, jeepers. Okay, yeah, 65 as opposed to 85. 95. That's way off from where it should be. So why don't we take a look at, let's just pursue this, because I'm going to test the rest of the tubes. I'm going to get too much in my head and I won't know what the heck I'm doing and forget it all. So what we'll do is we'll look at the schematic and try to sort out why or how that could be low. Shouldn't be too tough. Okay, so we're working on this tube. Plate here is supposed to be 250, and it was. The screen, what screen? What screen? What's happened to my mind here? Second detector. 6SQ7. There's no screen. Why are there two voltages in there? Something's going wrong here. Oh, yeah, I'm confused. That's what it is. 6SK7. I'm got my head in two tubes at once. That's no good. Okay, let's go back to the right thing here. Okay, we're back here. Back here. Yeah, there's a screen. So we have the plate here, and then we have the screen. No, that's not the screen. This first one is the suppressor grounded out. The screen is coming off of this wire here. Okay, so there's probably a controlling resistor somewhere. And again, it's also feeding this screen. So it's the wrong one. It's wrong in both. And there we are. 12,000. Let's just look a little lower here. What's going on here? So this guy is filtered. Look, they give the resistance of the speaker field coil here, 750 ohms, but still not the output transformer. So we have we just have a filter connected at this point. Let me go back up here. I've kind of lost track of what I'm doing. Yes, this is the screen wire. Looks like it's picking up its voltage through this 2-watt 12K resistor, R11. That's going to be one of those two big resistors, R11. So it's supposed to be 1, 2, 0. If you start with a brown, guess what? One of them is a brown body, so that's it. So we're going to check that resistor and see if it's still 12,000 ohms. Okay, now, so one side of the resistor should show full B plus, and the other side show the reduced voltage intended for the screens. So here's the big resistor, brown body. So here's one side, and here's the other side. Okay, so there's the side getting the feed, it's getting the full. It's getting the full, 250, and out of the other side is coming the screen voltage. Ouch, ouch, ouch. Screen voltage at, yeah, 65. So this resistor's probably gone high. So we'll shut off the radio. Which resistor? That one there that's now on the screen. Can we read that in circuit? I don't know offhand. I'd have to look at the schematic again, but let's just give it a try and see what we get. Give it a shot. Could be some voltage laying in there. Probably not. Let's just check and make sure. There's no residual voltage across here for some reason. Don't see anything. Are you 12,000 ohms? What are you? More than 20K? Is that what's happened here? Supposed to be 12 and it's actually 19. That explains the low voltage. It's a high wattage resistor, runs hot, takes a beating. Takes a beating, it's going to leave the world earlier compared to other resistors. So it's always worth checking out the high wattage resistors in these radios because they're the hard working guys. So we're going to cut them out and stick another one in there and we'll check that voltage afterwards. Okay, there's a 12K resistor in here now. I kind of fitted it up against the back apron to help cool it a bit. And I personally think it's better on these hot resistors to have a little bit longer wire to keep the heat from traveling down the wire. The original resistor was just barely fit in there with extremely short wires. So it's going to deliver a little more heat into the connection. So, and if you look at this really closely, this is supposed to be a brown, red body and dot. Brown, red with a dot. You can see the problem with the numbering system on here. So this should be brown body, red, can you see a little bit of red right there? Red on the end, body, end, and then the dot, I guess would be here, and it's that orange, looks like an orange band. So you can kind of make it out. And then the silver is the quality of it. The accuracy of it. Okay, we're ready to run this guy again. Let me just get rid of the solder before it ends up mixed up in the radio. Okay, power on. That's a big resistor there. What about those dim bulbs doing the normal thing? All is normal. Full power. Now we're looking for 95 volts on 6. So what do we got on the end of this resistor now? Are we all warmed up yet? Must be warmed up. $85, not quite 95. And on the other side, whoop, 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 on the other side. Just a hair under 250 now, slightly less. So it's just possible this lowered resistance is pulling allowing a little more current, maybe pulling down some voltages. What's with the crackling? Okay, we're on to the next tube now, because this one's done. If we just take a peek at the B plus on here. Well, that's right here. So that's not B plus. No. B plus. Yes. Well, it's done by wire. I don't remember. My memory is failing. That's the screen. That's the plate. Just under 250. Good. Okay, that will improve the screen voltage on the other tube too. So this is a twofer. And talking about the other tube, we'll move along. Just did the IF amplifier. The next one is the converter tube. So 245 volts on the plate of the converter tube, pin 3, bottom to the right. Converter tube's way up at the top here. Somewhere in there. There's the key. 1, 2, 3. Did I say 3? I did say 3. 3 should be 245, pretty much halfway up on the meter. I did this before, didn't I? Did I? I think this is 3 right here. That's the same plate voltage. Good. And the screen voltage, 245, 95 on pin 4. The next one over. Pin 4. 95. 150 volt scale. Same thing, just under 90, which is better than it was. Okie dokie, I think there's only really one more tube left. See if I can get it on the screen here. Yep. This is the front end, 6SK7 RF amplifier. It's going to have a plate and a screen. Plate again, this time 250. Slightly more for some reason. Plate, rate is number 8. Plate is 8. Okay, arm out of the way. Right here. No, that's grounded. Right here. On scale. Let's try again. So we get the same, just below 250. Same B plus as everybody else. And then the screen is 95. 2 back from there. Here. 95 here. Then it's 89. It's the same as the other. So a little low, but okay. In the meantime, these output tubes have been just cooking away here. Let's take a look. Take a look at how hot these guys have gotten here. I have my thermal viewer handy. That's why I want to do it. Just to kind of convince me that what I saw is what I saw. So this thing starts with the default with the red starting at 30 degrees, and everything's going to look red in here, of course. So we're going to change that. Select it. I'm changing the top temperature color here. Going up, until things get a little smaller. Okay, that looks good. Now you see 3 blobs for 3 tubes. Rectifier, output, and output. Clearly, there continues to be a difference. With the upper tube is the hot one. Okay, get it straight now. This is my chance to get this straight. The upper tube is the hot guy. And the hot guy is the tube. The upper tube is the hot guy. The hot guy is the guy with. That's B plus at 180. The cooler tube 230, 220. hotter tube that's the end of my statement there. Hotter tube, lower B plus. I mean, that's just so counterintuitive. Meanwhile, the screen voltages are the same. 70, what am I on? 500 scale. So it's 240. Wow. Just slipped off. 240. They really have to be the same because they're on a piece of shared wire. 240. Oh, you can't even see the meter. What'd I do? Did I bump the camera? I must have bumped the camera. Hey, where'd the meter go? Here it is. Okay. Yeah, I moved the camera. I moved the camera out of the way, I think. Anyway, you could hear what I was saying. Cooler tube, higher B plus. I don't know. It's not adding up in my head exactly, but definitely a dramatic difference between those. And must be the output transformer. So the output transformer, in fact, is sitting on here. How hot is that thing getting? Oh, that's a good question. I still got my viewer here. Okay, I'm gonna select the upper setting here, and then advance it upwards to, like, let's do high 70. Let's go down. Okay, I'm gonna bring down. I'm gonna make it so it will turn red at a lower temperature. There we go. So we can see can you see this stuff? You can't see it as well as I can. That's too bad. Okay, so anyway, the two of them, that's the field and the output, they're both registering similarly. And the actual temperature is 40 degrees at the top. The highest temperature on there was 40. I noticed before this thing gets pretty warm. Not sure that's unusual for this to get warm. Output transformers, I don't think they usually get warm. Ooh, that is definitely warm. It's comfortably warm, though it's not dangerously warm. Let this thing operate for a couple hours, though, to really get the full effect there. Wow, okay, so it's the first radio I've ever encountered with a serious problem in the output transformer. Do I have other output transformers? I do. I mean, I got a speaker right behind me. It looks almost the same as that one. But I'm not about to swap anything. Maybe there's something I can do to compensate in some way for it. Resistor that. I don't know. You're busy writing comments already. Great. Just be aware, I tend to never read the comments, or very, very seldom read the comments, for a whole number of reasons that if I went over them, you'd say, yeah, I understand. So even though you might be thinking you're saving me by writing a comment, you're probably just helping other people understand what's going on here in my shop. So anyway, where are we at now? We have discovered that everything is good. That's right. Everything but that output transformer. So I think I'm going to leave it at that today. Tomorrow we'll do the alignment again, attempting to do it with more advanced techniques and methods. And we'll see how that goes. So thanks a lot for watching, and see you tomorrow.